Right, so today we're going to look at section 1.2 and 1.3 part 1. So we're going to focus on using the graphing calculator a little bit in 1.2 just to kind of get used to how we can do some things on it. All right, so one of the first things the book mentions in section 1.2 is kind of something you've probably been doing, anytime you solve a math problem, the problem-solving process. Right, so the first thing you always want to do is make sure you read the problem. Okay, and as you're reading it, you want to really figure out two things. There's information that they're giving you, and there's information they're asking you to find. Right? You have to figure out which is which. Okay? Because if you can't figure out what they're asking you to find, you won't even know where to start to solve the problem. Okay, so as we go through a problem, we'll write down what they're giving us, and then we'll try to figure out what are they asking us to find. Okay, so once we've organized our thoughts and figured that part out, then we have to kind of start to figure out a plan to solve the problem. Okay, and depending on the kind of problem, there's many different approaches we take. In trigonometry, a lot of times we will draw a diagram. Okay, with triangles or things like that. Anybody think of some other approaches besides drawing a diagram on paper that we might use to solve a problem? Anything else? How about if I asked you, what are all the different ways you can arrange the letters A, B, and C? You wouldn't really draw a picture to do that. You might still write stuff down, but I don't think it would be a picture. Yep, Rachel?
You can kind of like imagine it, just like and see it.
Okay, what if, let's say, let's make it a little harder. Let's say I gave you the letters A, B, C, D, E, F, and I wanted to know every possible way you could arrange all of those letters. So for A, B, and C, there's not that many. There's only 6. So you could probably see that in your head. But if you had, like, say, 7, 8, 9 letters, all the different ways, it could be in the thousands. So what might be something you could do, or even use a computer to help you do? Yeah, making a list. Okay, that's another option. If it starts to get a really big list, then you're going to need like a computer or something to help us make that list. Sometimes we'll set up an equation. All right, so we might have a word problem that describes something, and then we set up an equation, and then we solve it. Okay, and even under solving equation, there's tons of different options. If it's a linear equation, okay, we might solve that differently than we would solve a quadratic equation. Okay, different formulas, different methods. Okay, and page 13 in your book, they have a whole list of different strategies for solving problems. Okay, and the last step, and then, is to actually try the method you think is going to work. If you want to try a picture, okay, now you actually draw out your picture, label things, and go from there. Okay, so any questions on that? That's just pretty general kind of information about problem solving, pretty much any kind of problem. All right. So let's try this example. All right, so we're going to talk about a company that rents cars, okay, and they charge you $15 to rent the car, and then there's a certain fee per mile. Okay, so $15 to rent the car, and then 20 cents for every mile that you drive it. Okay, when I go to set this up, I'm going to try to come up with a way to determine the total cost for renting the car. So what kind of problem-solving method do you think that would be? Do you think drawing a picture would be good, making a list? What does this one kind of say to you? Yeah, Allie? Yeah, we're going to set up some kind of equation. How many variables do you think I'm going to need in this equation? Yeah, go ahead, Amanda. Okay, we're going to need one for miles. I definitely agree with that. But what else is going to change here? And the thing I'm thinking of depends on how many miles you drive. So what you told me is what we call the independent variable. How many miles you drive, but something depends on that. Yep.
So you would like set up like a y equals mx plus b equation, and 15 would be b, and then 20 cents per mile would be the m, because that's the dependence, and then $15 is added just for the car, so you'd be solving for one.
Yeah, so we're going to really need two letters here, and we'll use x and y because really we can represent this as a linear equation. So I'm going to let y be the total cost because that is the dependent variable. And I'm going to let x be the number of miles driven. That's the independent variable. Okay, some people have a little trouble figuring out, well, which one is independent and which one is dependent. Okay, and the way I try to figure that out is I read it in my head and see what makes more sense. I say, does the number of miles I drive depend on the cost? That doesn't really make too much sense. Or is my total cost going to depend on how many miles I drive? Yeah. The cost is dependent on how far I drive. Okay? So cost is my dependent, miles independent. And there's other names for that. Sometimes we call it just x and y. Sometimes we call domain and range. All kinds of things. All right, so now let's write down an equation to represent that. Okay, and Rachel, you started to tell us what were you thinking for an equation here?
So you just substitute in the variables for y equals mx plus b, and then, so the 2 would be b, and then 20 would be x, or 20 cents.
Plug in 20 for x.
Oh, no, 20 for f.
Okay, so yeah, it's kind of like your slope. And there's your equation. Y equals 0.20x plus 15. Okay, so the 15 is a fee you only pay one time. The 20 cents you have to keep paying over and over for every mile you drive. Okay. Any questions on that equation? All right. So now let's use the model that we just came up with. Okay, this equation is a model for the word problem to find the cost for 50 miles. All right, so Andrew, if I want to find the cost for 50 miles and I want to use that formula, what do I do?
Plug in 50 with the x's.
Yeah, we're going to plug in 50 for x. Okay, so my cost for 50 miles would be 0.20 times 50 plus 15. Okay, so 0.20 times 50 is going to give me how much? 10 plus 15 is $25. So the cost to drive it 50 miles is $25. All right, let's do the cost for 100 miles. Now, can I just take the cost for 50 miles and double it to get 100? Many people think we can just do that. Just take 50, double it, and there's 100. All right, so those that don't think you can do that, why not? If I drive twice as far, why wouldn't it cost twice as much? Yeah, Zach.
Because if you do that, you're like also doubling the 15, which should be added after.
Right. That 15, that's a one-time charge. You don't want to double that fee. Okay? It is going to cost you twice as much for just the mileage portion, but we don't want to double the 15. All right, so we would get 0.20 times 100 plus 15. Okay, which is going to give me a total cost of how much? 35. Okay, so be careful. Sometimes you try to do shortcuts in your head and you think, oh, double the miles, double the cost, and you don't even think about it. But that's not right. Okay, 35 is the correct answer. Okay, any questions on that? So that formula we came up with, Okay, what we call that, or what our book's going to call it, is the algebraic representation of the problem. Okay, so if I were to just give this to somebody and not say anything else, they would have no idea what that is. They would not know that that's from a problem about a rental car where you pay 20 cents a mile to drive it. Okay, all they would see is that's an equation. And if they knew y equals mx plus b, maybe they would say it has a certain slope and y-intercept. Okay, but that's what the algebraic representation does. It kind of takes the word problem out of it and just makes it into something that's purely math, okay? Just an equation. All right, so example 2, based on the equation we just came up with in example 1. It says, suppose Sarah was charged $50 for renting the car. How many miles did she drive? Okay, what's a little different about this one? What's going on here? Ava?
You're substituting the y instead of x.
Right, this time they're telling me the dependent variable. Okay, they're telling me the total cost. They want me to find the independent variable. Okay, I'm finding x this time. Okay, so I'm going to take my $50 and we're going to plug it in for y. Okay, so we would get 50 equals 0.20x plus 15. Okay, and this one we're going to solve 2 different ways. Okay, we're going to do it using algebra first, and then we'll try to do it using the graphing calculator. Okay, and even using the graphing calculator, there's a couple different ways you can do it on there. All right, so if I want to do an algebraic approach to solve that, what would be my first step to solve for x? How about Tom?
Subtract 15 from both.
Perfect. I'm going to subtract 15 from both sides, which is going to leave me with 35 equals 0.20x. And Grayson, what would my last step be to get x by itself? Yep. I'm going to divide by 0.20 and 0.20. And if I do 35 divided by 0.20, how much is it? 175? All right, thank you. And remember, that's not a cost. That was miles. How many miles did she drive? Okay, any questions on that? All right. So now let's take a look at how we can do it on a graphing calculator. You could do a graphical approach with graph paper by hand, but we're going to try the graphing calculator. All right. So first thing I want you to do is, once you have your calculator, make sure you turn it on. And in the upper left, I'm going to press y equals. Okay, y equals is where you want to type in all your equations. Is there anybody that has a screen after they press y equals that's different than what I have? Okay, so let's go ahead and let me show you 2 different ways to do this. Okay, I'm going to look at this as 2 separate things. Okay, what's on the left and what's on the right. Okay, I want you to take what's on the left and I want you to type that in to y1. Okay, so we're putting that in y1, and we're going to take what's on the right and we're going to put that in y2. Okay, so to get to y2, you just press your down arrow. 0.20x plus 15. So visually, I want to see where y1 equals y2. What does that mean? What am I going to look for on the screen? I'm going to look for where something happens. Yeah, Amanda?
Where they cross.
Yeah, where they cross. Right, so I'm going to press, I usually start with zoom 6. That gives me the standard window from negative 10 to 10 on the x and negative 10 to 10 on the y. And as long as I see that little yellow thing in the upper right, that means the calculator is doing something, and now mine is done. So, any thoughts what's going on here? How come nothing is on the screen? Yeah.
Is it,
Yeah, it's what? Right. Okay, if you remember from Algebra 1, y equals a number. That's a horizontal line, right? Y equals a number. That's a horizontal line up at 50. My window is only going up to 10. It's way off the screen. All right? So I'm going to have to set my window much higher than 50. In fact, because I did it algebraically, I already know how high I need to set it. If I didn't know that, I would just have to play with it and change the window until I finally get one that works. All right, so let's set this. Let's say you didn't know you had to go to 175. I'm just going to set it to like 125. Whoops, and I want to do that on the y max. Now, if you look at the mins, x was miles driven and y is cost. Does it make sense to drive negative 10 miles? No. So really, the smallest number of miles we need to worry about driving is 0. And the smallest cost you could ever have is 0 if you didn't rent the car. Okay? So I'm going to hit graph now, and hopefully I'll start to see some of my picture. There's my horizontal line at y equals 50. And I can see that it looks like this line is going to cross it at some point, but it's still off the screen a little bit. Okay? Based on what we did algebraically, I already know how far I need to go over to x. X has to go all the way out to 175. And in fact, I like to go a little past it because you don't really want your intersection point to be right on the edge of the screen. It's kind of nice if it's in the middle of the screen somewhere. So let's set x max even higher. Okay, let's set it to like 200. And now I should see the intersection point, and I don't think it'll be right on the edge of the screen. Now this graph is fine. I think I set my y max a little too high. Okay, I probably could have set it a little lower because I'm not even using the top part of the screen, but I can see the intersection point pretty clearly, so that's okay. If you wanted, you could probably get away with your y max at like 60. Okay, you don't really need to go much above 50 in that case. Hey, does everybody have a picture that looks like that on the screen? All right, so now what I want to do is I want to find the intersection. Okay, there's a few different things that the calculator can find for us, and if you press second and then trace, okay, you'll see a list of options. And we're not really going to deal with options 6 and 7 this year. That gets into calculus, but we will do options 2 through 5 quite a bit. What do you think I want to look for here? 0, a minimum, a maximum, or intersect? Yeah. Yeah, we want to find an intersect. So I'm just going to press 5. Okay, and to find an intersect, what you have to do is pick a point on the first curve, pick a point on the second curve, and then take a guess roughly where the intersection is. Okay, the reason they have you pick points on each curve is because you could have more than 2 graphs on the screen. All right? So maybe if you had a green line coming down, you might want to know where the green line and the blue line cross. Or maybe you want to know where the green line and the red line cross. All right? You've got to tell the calculator which 2 lines you want to see the intersection for. In this case, we only have 2. So not a big deal there. So just pick a point anywhere on the blue line, hit enter. You can pick a point anywhere on the red line and hit enter. And then the guess, It doesn't really matter where you put the guess. The calculator is going to find it, but just try to go over close to where they cross. The guess is really only important if you have more than one intersection on the screen. Let's say you had like a parabola and something like that. Wherever you put the guess closer to which point, that's the intersection point it'll give you. So if you put your guess closer to this one, it's going to give you that intersection point. If you put your guess closer to this one, it would give you the other one. Okay, that's the only time the guess is important. So this one, even if you put the guess way over on the left side of the screen, it would still find it because there's only one on the screen anyway. Okay. And it tells me exactly what we figured out algebraically. Okay. X is 175, Y is 50. Okay, so that's how many miles you drive. And that is the cost. Right, so that's one way to find the solution to this problem graphically. Any questions on that one? Hey, there is another way, but I'm going to hold off for now, and it'll come up a little later on. All right, so when I graphed this at first, it was off the screen. Okay, what we just found after we fixed it and we made it on the screen is called a complete graph. Right, so a complete graph is basically a window on the calculator that shows you all the important things you need to see. It doesn't cut off anything that's important. So if in the homework they ask you to find a complete graph, all you have to do is write down your window. Okay, your window is your x-min, your x-max, your y-min, and your y-max. That's it. Okay, and the way I might give you a test question on that is I will give you, I'll give you a couple graphs. I'll ask you to graph them. And I'll give you 4 different choices of windows. And I'll say which one is a complete graph. Which one shows me all the important characteristics of what I'm trying to see. And a complete graph doesn't always have one answer. Okay, you might have that as a window. If somebody else did, let's say something like this, I would also accept this as a complete graph. Okay, what I'm really looking for in this problem is, are you showing me where the intersection occurs? If that's off the screen, it's not a complete graph. All right, so for this one, I want to graph that shape, and I want to find a complete graph. Does anybody know what this is going to look like when we graph it? This is not linear. This is going to be curved. But what shape is that going to be when you graph something squared? Okay, like a U shape. Yeah, does anybody know what that's called, that U-shape thing? Yeah, parabola. Okay, so that's going to be a parabola. And a lot of what we do when we study graphing parabolas in a later section, we're going to talk about how you can put different numbers in different spots and what they do. But without studying that, does anybody know what this plus 10 is going to do? Yes, when you put a plus 10 at the end like that, it's going to shift it up 10. We could also shift left and right. That's not happening here. All right, but that's going to shift it up 10. So I'm going to go back to my y equals. Okay, and I'm going to clear out everything I had and type in x squared plus 10. Okay, and I'm going to start with zoom 6. And before I even press it, what am I going to see on the screen if I use a standard window? Yeah, nothing. because standard window only goes from negative 10 to 10 on the x and the y-axis. I've shifted a parabola up 10. And if you know a little bit about a parabola, when it has a positive coefficient, that's when you get the U shape. So 10 is like a minimum value, and it's going to go up from there. All right, so what value could I change here so that I start to see the parabola on the screen? How about Francisco? Yeah, which y value, the min or the max? Yep, the max. And what do you think I could change it to? 50? Yeah, we can try it. Let's see how that looks. Yeah, I'd say that's pretty good. That's a perfect picture of a parabola. Okay, a complete window for a parabola, you're basically looking, can you see the minimum or the maximum, depending on which way the parabola is flipped. Right, so what I would write down for my answer, all you have to write down are these four values. X min, X max, Y min, Y max. Did we talk about the X scale and the Y scale in here? Okay. That really has no effect. It just changes the tick marks you see on the screen. All right, so that curve that we just drew, that's called a parabola. Okay, and the general form of that, we often see that as like a quadratic equation. Okay, and the general form is ax squared plus bx plus c. If I have to graph a parabola, I do not like it in this form. Okay, because if you give me a parabola like this, I can't look at it in my head and tell you how much it's been shifted up, down, left, or right. If you give it to me like this, in a factored form, not doing this out, I can tell you exactly what's happening here. This is a parabola that's been shifted left 3 units and down 4 from the origin. But if you use your distributive or FOIL property and do all this out, and then subtract 4 from it, I probably wouldn't be able to do that in my head. Okay, so general form of a quadratic, that's the ax squared plus bx plus c. But I like this other form a little bit better. All right, so let's find a complete graph for this one. Square root of x plus 20. Anybody tell me anything about square roots that they know? Like kinds of numbers you can take square roots of? Okay, you could take the square root of a perfect square and get a nice answer, but can you take the square root of something like 5 and it still works? Yeah, it still works. You don't get a nice answer. Is there anything you can't take the square root of? Negative numbers. All right? So that might give you a hint at what you're allowed to plug in for x. You could not plug in negative 100 for x. Because when you do that out, you'd have the square root of negative 80. That wouldn't work. Can anybody tell me what numbers I could plug into that equation? Keeping in mind that what's underneath this square root cannot come out negative. Yeah, Amanda? Okay, I agree with you. You can definitely plug in all the counting numbers, but I even think you can plug in some negatives too. Like I could do negative 1. If I plug that in, I would still end up with a positive number under this root. But all numbers from what?
Like anything that's like more than negative 20, right?
I agree. You can plug in everything that's greater than negative 20, and I also think there's one more thing you can plug in, other than just greater than negative 20. Or equal to. You can use negative 20 as well, because you can take the square root of 0. All right. So let's plug in. Well, we'll graph it, and let's see what happens. Okay, so I'm going to type in square root of x plus 20. And I'm going to fix that. Okay, if I go to graph it right now, I don't know if you can see it, but it left this little dotted box here for an exponent. It's probably going to give me an error. Okay, you also have to press delete and get rid of that little box. All right, let's do zoom 6. And if I asked you for a complete graph, which I am here, I would say that's not it. To me, that almost looks like a straight line, but if we know a little about square roots, they are not straight, they're more curved, right? So we said the smallest value we can plug in is negative 20. Let's go and set our x min just after that, negative 25. Okay, and let's hit graph now. Now I can definitely see that it's curved. And I can see that it's starting right where x is negative 20. The graph doesn't even exist to the left of that. Okay? Because if you try to plug in negatives, you're going into imaginaries, and this calculator can't graph imaginaries. Okay? So for a complete window, that, what I have right on the screen, that's perfect. I'll just put this over here. Any questions on that? All right, so as we start graphing, you'll get used to different graphs and kind of what they look like and what to look for. Especially looking like for how many turns a graph can take. Okay, we're gonna learn something that'll help us figure that out too. Because if a graph is taking many turns, you want to make sure you always see all the turns on the screen. Okay? But we'll get into graphs like that more later on. All right, so last thing in section 1.2 is they ask us to graph just individual points. Okay, not an entire line. But we'll just graph these points. Okay, and we don't even need to graph them all. Once you graph a few of them, you kind of get the idea of what's going on. But if you want to type them all in, you can. And let me show you how you do it. All right, so to graph these points, the first thing we have to do is press stat. Okay, stat is right below the delete key. All right, so if you're in another screen at this point, I'm just going to get out of it. And I'm going to press stat. Okay. Next step, it says go to edit. Okay, so on my calculator, once I press stat, I think edit was the first thing that was right there. And I'm going to press enter on edit. Now I've got all these different lists I can type things in. Okay, what I'm going to do is I'm going to type all the x values in the first list, L1, and I'm going to type all the y values in the second list, or L2. Now you don't have to do it that way, but if you do, it just makes things a little easier. All right, so my x's go from negative 3 to positive 3, just going up by 1. So just negative 3, enter, negative 2, negative 1, 0, 1, 2, 3. Okay, anybody have a problem getting to that screen or typing those in? Now, on your calculator, if you already had numbers typed in there, like let's say somebody used it before and you had to get rid of numbers, well, you don't really have to get rid of them. You can just highlight and you can just type right over it. Or if you really want to get rid of everything, just press delete and it'll get rid of the numbers that are there. But do not go to L1 and press delete, because if you do that, it's going to delete that whole list from the calculator and then we have to reset it to get it back. Right. And now type in your y values. Negative 18, negative 2, 2, 0. Am I okay so far? Yeah, negative 2, 2, and 18. Hey, anybody have trouble getting all those typed in? All right, so once they're typed in, just press second quit, and you can get out of that screen. And now we're going to go back to where we graphed something. We're going to press the y equals button. And we're going to go to plot 1 and hit enter. So let me show you where that is. Plot 1 is right at the top. Okay, so to get up there, you just press your up arrow. And now it's highlighted. Hit enter. And now you can see it turned on plot 1. All right, now before I hit graph to see what I just did, what I want to do is kind of think about my window. What's my largest and smallest x value? How about Zach?
It's x is 3 and then negative 3, and then y is negative 18.
Okay, so I want to set my window keeping those values in mind, but I really don't want a point to be right on the edge of the screen. So if my largest and smallest x values are negative 3 and 3, what do you think good numbers to use for x min and x max would be? Just so we have a little extra on the side, yeah? Yeah, I would go negative 5 and 5. And now my y's are negative 18 and 18. So what do you think we should do for the y min and the y max? Yeah.
Negative 20.
Sure, let's go negative 20 to 20. And now when I hit graph, everything should be set up so that I see. I must have something else still typed in. I think that's the square root. If you still have that square root, you don't want to see it, you can just clear it off. Hit graph, and there's your points. Okay, this is not a parabola because it's taking 2 turns. Okay. If I were to draw a line through it, it's a cubic function. Yes?
Can I see the last step?
Yeah, the last step is just to go to y equals, and you turn on plot 1. And there's all different kinds of graphs you can do. We just graphed points. I think you can even do a bar graph. You can do all kinds of things, but we don't spend a ton of time. I just wanted to show you how you can put in points and graph them.
When I graph my points, it's like connected dots. Is that?
Yeah, so that's just a setting. If you go to second stat plot, I can choose what kind of plot I want. So let's see, if I go to that plot, the type I did was the first type. Your type is probably set on that one. That's going to connect them. I can do bar graph. It almost looks like a box and whisker, some other kind of weird box and whisker, and then something else, I'm not sure. So did yours look like that?
Yeah.
Yeah, so it had connected them. Yeah, that's just a setting under second stat plot. You can change the type. You can also change the color of the points. You can change which lists you use. I told you guys just use L1 and L2. It'll be easier. So I didn't have to even explain that part to you. But the other thing you can do, which is pretty neat, okay, and this part, you don't have to do this. I just want you to watch it. If I go to stat, I can calculate what's called a regression line. A regression line is basically like a line of best fit or curve. It tries to say, all right, what function would go perfectly through all those points? Right? And the calculator can figure that out automatically. I know it's turning twice which tells me just from what I know about functions, it has to be a cubic function. If it was a quadratic function, it would only turn once. It would be a parabola shape, and that's not a parabola. So again, I'm just going to show you how this works. Just going to go to calculate. And it tells me that the function that would go perfectly through all those points, I just plug these numbers into what's above. So it's x cubed plus 0x squared minus 3x plus 0. Right, so I'm going to type that in. X cubed minus 3x. X cubed minus 3x. So that is the function that goes perfectly through those data points. Anybody think why that would be useful? Why would you want to take and fit a function to a set of data? What would that be useful for? Think about like maybe science. Like if, let's say maybe this table of data was lab results from something. What would finding a formula for this data let you do? Yeah?
You could kind of like predict your results.
Yeah. So you could make a prediction and say, well, if x is 4, I could say if x is 4, I should get a y value of 52 based on the results I have so far. Okay? And of course, you can confirm the results you already have by typing them in and making your own table. All right. So again, not something we do a lot with, but something you might be able to use if you ever had to find a function to fit data. Okay, it's pretty neat. Calculator can do it for you. Okay. Oh, and the last step to actually see your picture, I didn't show this one. You have to press graph. Until you press graph, you won't see anything on the screen. Right, so any questions on that before we finish up with, we're just going to do part of a section. We're not going to have time to do the whole thing. All right. Right, so section 1.3 starts to talk a little bit about functions. Okay, what a function is. Okay, in the example we had about the rent-a-car, okay, that was a function. Okay, we didn't call it that necessarily. We called it like an algebraic representation, or we called it an equation, but it's a special equation called a function. And does anybody remember, what were some of the names that I called the y value? There's like 2 or 3 different names you can give to it besides the y value. Yep, Josh?
Range.
Yep, you can call it, it's the range of the function. What else did we call it? Yep, Allie?
The dependent variable.
Yep, the dependent variable. Okay, and we called the x basically the opposite of that. It was the independent variable. And what's the name for x that corresponds to range? Y is range, x is domain. Okay, so there's all kinds of different names. Okay, one I didn't mention, input and output. I kind of think of input, it's like a machine, like this formula. If you plug in how many miles, you put that into the machine, what'll come out is the total cost. So that's the output. You input how many miles you're going to drive, and the output will be the total cost. Okay, does anybody remember what a function is? Not all graphs are functions. For example, a circle is not a function. Okay, some lines are functions. Not all lines, but some are. Anybody remember visually what has to happen if something's a function? It has to pass a certain test. Anybody remember the name of that test? You remember, Amanda? You thinking? Oh no, I'm sorry, Molly.
I know what you mean, like when you drag your, the pencil test, like that's when you call it, not the pencil, but like, yeah,
Maybe, I'm not sure. Anybody help her out? What? There's a certain test it has to pass visually if it's a function. It's the something line test.
Yeah.
One word in front of it. Because there's actually two different line tests. Anybody remember the name of it? Begins with a V? The vertical line test, yeah. So if we want to think about it visually, if a function passes the vertical line test, it means it doesn't cross. There's no way to have a vertical line cross your picture more than once. Okay? If that's true, you've got a function. No matter where I put a vertical line here, it's never going to cross more than once. Okay? That's a function. That's not a function. Okay? A circle is not a function because if I put in a vertical line, it will hit it more than once, or it's possible for that to happen. Right? So algebraically, basically what we say is for each x value, there's only one y value. Okay, with a circle, the problem with that is if you go a certain amount, you could go up to this y value or down to that y value. Those 2 points have the same x value. That's not a function. Okay, so to have a function, for every x value, there is only one y value. Okay, and there's many ways you can say that. For every input, there is only one output. For every value in the domain, there is a unique value in the range. You can use any of the terms we've used up above. Okay, the book does word things a little differently sometimes, and when I notice that, I try to make you aware of it, especially with directions in the homework. So some of the things that I might erase, it's because I think it's more confusing the way the book words it, and we'll just stick with the way I worded it. Okay, does everybody have the definition of a function? Right, we kind of already mentioned this. The domain is the set of all the x's. It's the set of all the inputs. And the range is the set of all the y values. It's the set of all the outputs. Okay, basically just said that at the beginning of this section. Okay, unless otherwise stated, the domain is always a real number. Okay, we will not be talking about imaginary numbers for a little while. So unless the problem says otherwise, always assume that the domain is a real number. Okay, when we write something as a function, there's a couple different ways we can do it. One is the way we've been doing it, y equals notation. But then we also have this other notation below it. Does anybody know how you pronounce what's on the left-hand side here? What is it? Yes, f of x. Right, just a different way, different notation for a function. What's nice about f of x is if you had multiple functions, then you can name them. So let's say I had another one, g of x. Now, if I'm talking about these functions on the board, I can say function f or I can say function g, and you know which one I'm talking about. Versus if I do it like this, now I can't say the one that's y equals, I have to say the point 2x plus 15 or 3x plus 5. Okay, so the f of x notation is a nice way to name a function. And you can use any letter. F of x, g of x, h of x, doesn't matter. Okay, any questions on those notations? you don't like f of x, anytime you see it, just change it to y. Okay, if it looks confusing, just know they're the same thing. All right, so we kind of did one like this in the last section where we found a complete graph, but now I'm asking for the domain and the range. Okay, and domain and range is something that people usually kind of struggle with. So visually, when I think domain, when I make a graph of this, I'm thinking, when I look at the picture, how far left and right is it going to go? Okay. When I'm thinking range, that's y values. Looking at the picture, how far up and down is it going to go? Some functions go left and right and up and down forever. Think of a diagonal line. Goes forever left and right and up and down. This does not. Okay. Based on what we did in section 1.2, anybody tell me what values for x I'm allowed to use in this function? What values of x could I use in the domain? Only certain ones. Like, for example, negative 20 is not a value I could use. It's too small. Yeah? Anything greater than 3? I pretty much like it. Is this a small tweak I want to make? Equal to. Yep. So the domain is any x value greater than or equal to 3. That's one way to write it. Another way to write it, which we're going to see probably in the next section, is called interval notation. You can pick any number from 3, including 3. Remember, bracket means you include it. Parenthesis means you don't. Okay, so any number from 3 up to infinity, and you can never reach infinity. So we always use a parenthesis with infinity because you can't reach it. These mean exactly the same thing. From 3, including 3, up to infinity, not including infinity because you can never reach it. All right, and let's do the range. Let's graph it, because if you're not familiar with square root functions, you might need a picture. Square root of x minus 3. Already got an idea of my domain. It's from 3 to infinity. So I'm going to set it at 0. I just don't like my graph to be right on the edge of the screen. How high is it going to go? Well, it goes to infinity. So, I mean, I can set x max as high as I want. And let's just put this back at the standard window. Negative 10 to 10 for the y's. Okay, now I still have my stat plot on from what we did before. So if I hit graph right now, I'm going to see all the points in my stat plot. So before I do that, I'm going to go back to y equals. I'm going to go up to plot 1, and I'm just going to turn it off. If you don't turn it off, it's not a big deal. It's just going to be in the way of what else is on the screen. Now I'm going to hit graph. Okay, so what does it look like the lowest y value I ever get on that graph is? Yeah? 0. In fact, that occurs when you plug in 3 for x. The square root of 3 minus 3 is the square root of 0, or 0. So the range is going to be all numbers greater than or equal to 0. This graph is never going to stop going up. Think about what happens when you plug bigger and bigger numbers in for x, like 1 million. 1 million minus 3, take the square root of it. 10 million. 10 million minus 3, take the square root of it. The square root's just going to get bigger and bigger and never stop going up. Anybody think they could tell me how to write the range in interval notation? It's very similar to what we did for the domain, just one number is different. Yeah?
Bracket, 0, comma, infinity, parentheses.
Right. So bracket, because we're including 0, it is equal to 0. And it goes as high as infinity, but we can never reach infinity. So parentheses. Okay, I just want you to get used to both notations. Yes?
If, like, on a test, we don't add a parenthesis and you put like a bracket, or we put parentheses for both, are we gonna get points taken off?
Yeah, if you put a parenthesis on that 0, what you're saying is that. That's the difference, if you put a parenthesis on it. Yep. So you just have to be careful with your bracket and parenthesis. Always use a parenthesis on infinity, because you can never reach it. Whether or not you use a bracket or parenthesis on a number depends, is it equal to, or just a greater than, or less than. All right. Let's think about this one before we graph it. What shape is this graph? We've seen this one a couple times. Yeah, Josh? Yep, it's a parabola, and it's been shifted which way? Again, this is a little more advanced question. We're going to get to this later, but Pacey?
Down 4.
It has been shifted down 4, and it's opening up. So in my head, I'm already thinking of a shape like this. All right? So domain. What values are you allowed to plug in for x? And if you get confused with that, say to yourself, is there any number you're not allowed to square and then subtract 4 from? Is there any number that if you tried to square it on the calculator, it would come back with like an error? What do you think, Tom? You can square 0. You can do 0 times 0. You just get 0, so that's okay. Sure? Anyone help him out? Is there any number that you can't square? Like there are certainly numbers you can't square root, negatives. But how about square? Yeah. Yeah, you can square anything, right? So the domain here can be any number you want. You can plug in 1,000,000 if you want for x, 2,000,000, negative 10,000,000 divided by 3. It doesn't matter what you plug in for x. Okay? You would never get an error for anything you'd plug in. Okay, so the domain, I'm going to write it as negative infinity to infinity. The other way to visualize it is think of a parabola. How far left and right does a U-shape go? Well, it's going to go forever. Not very quickly, but that U-shape is still going to grow forever, left and right, and it's never going to stop. Now the range. Does a parabola go up and down forever? No. Okay, this parabola is going to have a minimum value, and it's going to go up from that minimum. You might already have an idea what it is, but let's type it in because I can show you something else that the calculator can do. All right, so I'm going to type in x squared minus 4. If you have anything else there, just clear it out. Standard window will work perfect for this, negative 10 to 10, so just do zoom 6. And this shape is going to have a minimum and go up forever. We did something earlier, and it was under a different menu, but did anybody see something that we could calculate other than an intersect that might be helpful here? If you go back to that menu where we found an intersect, there's something there that's going to help us. Yeah?
The graph's minimum.
Yeah, we want to find this time a minimum. So if you go to second calc, go to your third option. This is a little different than an intersect. What you have to do to find a minimum is pick a point that's somewhere to the left of your minimum. Hit enter. Pick a point that's somewhere to the right of your minimum and hit enter. And you should see 2 dotted lines on the screen. And that's, you just told the calculator, I want you to look for a minimum between those 2 dotted lines. Okay, and the guess, just go as close as you can. It's not overly important. And I get this 1.46 times 10 to the negative 6. So that's like saying x is 0.000001. And y is negative 4. So if it's saying x is 0.000001, what do you think x should really be? It should be 0, but the calculator, remember, it's just trying to do programming inside this machine, so sometimes things look a little funny. It really, the minimum is at 0, negative 4. Okay? So what's the lowest y value that I ever hit? Yeah, Rachel?
Nothing, so it would be like greater than or equal to?
Yes, it's going to be everything greater than or equal to negative 4, or if you want to write it as an interval, everything from negative 4, including it, going up forever. Okay, I'm going to hold off on doing another domain and range. That's a good one you can practice. The only thing I want to show you here is how you type in absolute value, because that's a little different. Okay, to type in absolute value, you go to math. You have to go over to number, and it's the first option. Okay, and this will be in the video too if you need to see it again. But you go math, you go to number, and it's the first option. And now you can type in whatever you want. X squared minus 4. Okay, and if you graph it, you can kind of see how that changes the domain and range. It doesn't really change the domain. It's still going to go left and right forever. But remember what absolute value does. It takes anything that would have been negative and it flips it up and makes it positive. So that's why this piece right here, it's been flipped up. So your range has changed here. It's no longer negative 4 to infinity. It's actually going to be 0 to infinity now. That's what I just basically told you. Okay? If you want to graph something with an absolute value, any part that goes negative, just flip it up. If you wanted me to graph the absolute value of that, this part would get flipped up, and this part would get flipped up as well. Okay? Just flip up the negative parts. All right, so evaluating a function, basically that means we've already done it. You just plug in a value for x and simplify it as much as you can. So what they'll usually do is they'll give you a formula. They'll give you a value they want you to plug in. You just plug that value in for x and simplify it. Let's take a look at the first one. To evaluate x squared plus 1 for negative 2, I'm just going to plug in just like that. And if I plug negative 2 in and do out the arithmetic, what will I get? About, listen. What will I get if I plug in negative 2 for x?
4 + 35.
Yeah, maybe 5. That's it. Okay, if I plug in 3, I got 3 squared plus 1, or 10. What if I plug in a for x? What would I get in that case? About 2. Yeah, when you plug in a letter, sometimes there's not much you can do. It's just a squared plus 1. And how would I deal with this one? What if I plug in x minus 3? I do that out? That I can simplify a little bit. Well, Francisco, you remember how to simplify that? What does that mean? X minus 3 with a little 2 up high. Yeah, it means to do x minus 3 times x minus 3. Now, you remember how you do that out? Yeah, FOIL, or some people call it distributive. And you're going to get x squared minus 6x. And what's my constant going to be when I combine everything together here? About Kayla?
Plus 10.
Yeah, plus 10, good. Okay, so definitely a skill from Algebra 1. I just want to make sure people remember is that distributive property. Any questions on that? All right, so second to last, just about done. So I said to you earlier, not all equations are functions. Okay, y squared equals x. That's not a function. Okay, because if you were to try to graph this, you've got to get y by itself. And to undo squaring, I take a square root. So these equations are the same thing, just the bottom one I got y by itself. That's not a function. If you graph it, it would look like this. Kind of look like a parabola on its side. Why is that not a function? Yeah? Which test? The vertical, yes. There is a horizontal line test. We'll talk about that much, much later. That fails the vertical line test because there's an x value right here that has two y values. So the vertical line test states that if a vertical line hits a graph more than once, very simply, not a function. So is a vertical line a function? You think, Casey?
No.
No, definitely not. A vertical line, if you draw a vertical line, hits it how many times? Infinitely, every time, right? So vertical lines are definitely not functions. That's why I said to you earlier when I was describing what a function is, I said some lines are functions. Basically every line except a vertical line. So I think that's a good stopping point for 1.3. When we come back next time, we'll finish up 1.3 and continue on from there. Okay, so the homework, kind of one of those weird weeks where we're not having a test on a Friday. So if we do have a test on a Friday, there's generally no homework because we didn't have a test this week. I'm going to give you a little bit to do on 1.2 and 1.3, but you have 10 days to do it. Some of it is just doing stuff on the graphing calculator. So you might ask, like, well, what do they want me to write down? It's just practice with the calculator. If they ask for a complete window, make sure you write down your x min, your x max, y min, y max. All right, so at page 20, that was the first section. It's 1 through 10, 18, 20, 21. I'm sorry, 18, 21, 29, 32, and 38. And then on page 30, 1 through 8, 11 and 13, 16 through 19, and 24. We'll take a look at that first thing next class.